Hello guys, in this lecture we'll talk about building global variables. Solidity has some global variables that are very important and are used in many smart contracts. The first and the most important global variable is the MSG variable. This variable contains information about the account that generates the transaction and also about the transaction or call. The variable has some members. The first is the sender. So msg.sender keeps the account address that generates the transaction. Let's check it with one example. I have my test smart contract that we've used before, and I create a new state variable named caller. So address public caller. And now in some setter functions, because only setter functions can modify state variables, let's say here, I update the caller variable with msg.sender. So caller equals msg.sender. I modify the caller variable also here. So caller equals msg.sender. And now I deploy the contract. I'll use the JavaScript virtual machine, the in-memory blockchain. It's easier to test simple contracts. I deploy the contract has been deployed, and now I modify the price. Let's say price 5, set price, and now I want to see the value of this variable, of the caller variable. So the caller variable has this value. What is this address? Is the address that executed the transaction created when I called the set price function. So if we go here up, we can see that this address that starts with CA3 is the caller. Now let's change the account. So I take another account, the account that starts with 583, and I call the function set location. Let's say the location will be London. Set location. Who called this function? This function has been called by this account, the account with this address. So if I press on caller, the value of the caller is the address of the account that executed the transaction. I think everything is clear about msg.sender. msg.value represents the ether value in way sent to this contract. Okay, let's check it. This is very important, for example, in ICO smart contracts, or if we have a token, an ERC20 token. We'll have some full examples in another chapter. So let's say I create another variable of type uint, public, last sent value. An user will call a function sending some ether to my contract. In order for my contract to keep a balance, I must have a payable function. We've discussed about this. So this is my payable function, send ether, and here inside my payable function, I'll update my new state variable. So last sent value equals msg.value. Okay, I erase all deployments and I deploy the contract one more time from this account. So deploy, the contract is deployed, and now another account, this account for example, sends 50 way to my contract by calling the send ether function. Okay, the function has been called. If I check the balance is 50, and if I check the value of the variable named last sent value, it's also 50. Now another account sends, let's say 100 way to my contract calling this function send ether. Okay, the balance is 150 way and the last sent value is 100. So the last sent value, this is the msg.value global variable, keeps the value sent to my contract in a transaction. Let's see the next global variable. So msg.gas represents the remaining gas of my transaction. This variable will be deprecated and will be replaced by the function named gas left. Okay, let's test it. I create a function here, let's say function f is just a name, it doesn't matter. My function is public and my function will return an unsigned integer. Okay, I want to check the amount of gas that will be spent by this function. So I want to know how much gas will this function spend. So I create a variable, let's say unsigned integer start equals gas left. And now I have some operations that I want to see how much gas they consume. I'll create a for loop for uint I equals 0, I less than 10, I plus plus. This is the classical for. And here I have an operation, a simple operation. Let's say j plus plus. And here unsigned j equals 5. This is an example, just an example. I want to know how much gas this function consumes. Return start minus gas left. At this moment, my transaction can spend the value of this variable, so the value of the start variable. The instruction inside the for loop will consume some gas, and then I'll return the difference. Let's test it. I deploy the contract. Okay, this is a function that doesn't modify the blockchain and must be a view function. So here I must specify view. This was the problem. This is why we see the f function in red. So I deployed the contract one more time. Now f is in green. This is a getter function or a function that only returns. It doesn't modify the blockchain. And I press on F. And we can see my function consumed 800 gas. The execution of a transaction costs 21,000 gas. So this value is without those 21,000 gas. So in total, if I want to see the total amount, will be 21,000 gas plus 800. So 800 is only for these operations, for my for loop. Okay, this is msg.gas. msg.data represents the data field from the transaction or call that executed this function. Then we have this variable. This is the current contract and it's explicitly convertible to address. For example, if we want to get the balance of a contract, we get like this dot balance. I've used this way of getting the contract balance here. Yeah, get balance. Okay, the balance is 0 because nobody sent Ether to my contract. Then we have the block global variable with many members. The first member is timestamp. Block.timestamp is an alias for now and returns the Unix epoch. The Unix epoch represents the number of seconds from the 1st of January 1970. So I can represent any time, any date as a number of seconds that passed from that date. Block number represents the number of the current block. Block difficulty is an uint value that represents the difficulty of the current block. The block gas limit determines how many transactions can fit in a block. For example, if the block has a limit of 100, then we can have transactions inside this block that together their gas limit is no more than 100. So we can have, for example, a transaction with a gas limit of 10, another with 50, this means 60, and another transaction with a gas limit of 40. This is not like, for example, at Bitcoin, where the maximum block size is 1 megabyte. And transaction gas price represents the gas price of my transaction. I've created a smart contract named global variables, and I declared some state variables that are initialized with my global variables. For example, this moment equals now. Let's see what's inside the variable named this moment. So I deploy the contract, and I want to see what is the value of this moment. So the value of this moment variable is this big value from here. Okay, what is this value? What's the current date and time? So I copy this value and I search for Unix epoch time. I have this converter and I paste this value, the value returned by this moment. Okay, this is the current date. Now, it's an alias for block.timestamp. So now has the same value. We see that now and this moment are the same. Block number represents the block number. This is very simple. This is the block number. This is the block difficulty. This is the gas limit. And this is the transaction gas price. We'll use these Solidity global variables in the smart contracts we'll develop in the next sections, so it's important to understand and to use them correctly.